Hi, welcome back to my channel. My name is Pahu. So last year I have a video talking about how to create a pull request for AWS CDK like this to add metadata support, metadata options support for launch template. It was last year, 1 year ago, but it was great because we walked through a real pull request to address an issue. So today I'm gonna talk a little bit about another issue we recently had. So this issue is about disabling cross-zone load balancing not respected in Java CDK. So I'm gonna share how I triaged this issue and how I address this issue with a pull request by walking through from scratch. So hopefully this video helps. Can inspire you a little bit about CDK. Okay, let's get it started. Okay, so looking at this issue is about application load balancer construct, and it's in Java. But generally, the issue happens in every language CDK supports. So if this issue happens in Java, it is very likely we are going to have this issue in TypeScript as well. So this is the application load balancer construct with the property crossZoneEnabled as false, but it is not respected. So what I'm gonna do now is I will create a very simple, tiny application load balancer using CDK in TypeScript with this option to false, and I'm gonna CDK things and deploy. Let's do it. I'm gonna open my local VS Code IDE. Okay, so I like to create a stack like dummy stack and to experiment anything in this dummy stack. So in this dummy stack, I'm gonna create a dummy ALB load balancer, probably NLB as well. So we need to make sure that we import elasticloadbalancingv2 as ALB v2. Then application load balancer, right? Okay, so we need a VPC. Yep, so I got a default VPC. This is my private function. So I have VPC, and what else we need? Nope. So I'm gonna do AWS SSO login to authenticate myself. Okay, good. And this is dummy stack. So in the apps TypeScript, I'm gonna synthesize this stack only. So okay, dummy stack. Okay, good. Okay, so load balancer is created. Let's go to the CloudFormation console. Okay, CloudFormation resource ALB, click. Okay, our ALB is here. Okay, so by default, the ALB cross zone load balancing is turned on. Okay, so let's try to turn it off. Like I guess we should have a property like cross zone enabled. Let's see if we can make it false. And I like to run cdk diff. Okay, so this is not usual because when we update our CDK stack, it should have a diff return, but obviously it is not honored. So I guess this issue makes is relevant because we cannot turn on the cross-zone enabled option. So let's see if we can turn it off from the console. No, not possible. Availability zone routing configuration, you cannot turn it off. So let's check the CloudFormation document. So it probably makes sense you cannot turn it off, but you should throw an arrow in CDK that you cannot do that instead of just do nothing, right? So I think we still should improve that. But let's check the CloudFormation document. Load balancer, okay. Load balancer attributes here. Okay, load balancing cross-zone enabled. Indicates whether cross-zone load balancing is enabled. The possible value is true and false. The default for NLB and GLB is false. The default for ALB is true and cannot be changed. Okay, so this cannot be changed for ALB, which is true from what we observe from the console. So, but the CDK experience is not relevant. So I'm gonna see what's going on in CDK. Okay, so I will check this construct class. So I generally go to aws-cdk GitHub and I will search the class and the L2 construct name like this. So I will generally the first result would be the source of this construct class. So I just jump into this construct here and I'll see how the property is handled. So I'm gonna scroll down to see the constructor here and check how that property is handled. But let's see, cross zone, nothing. Okay, if nothing is found here, this means that it could be handled in the base class. So the base class is the base load balancer. So let's go to the base load balancer. Just highlight the name and it should be here. Okay, let's check the base load balancer. So scroll down. Let's check the cross zone. Okay, looks like we have a property for the base load balancer class, and this is where this property is handled. Okay, so if the cross zone enabled, if this, then set this attribute to true, but it is not handling the when it is false. So I guess we should improve here, because when user specify this property to true, we should pass all the way down to the L1 construct property to true. And of course, when user specify false, we should pass to false. And if there is any specific exception, we should throw the arrow in CDK rather than throw the arrow in CloudFormation. We should fail earlier, right? So I guess we probably should improve here. So if this property is not undefined, which means it could be either true or false, right? Explicitly true or false, then we should pass the boolean all the way down to this attribute. But I guess only ALB is not allowed to set to false. So we can throw an arrow when we are aware that this is for ALB, so it will not deploy to it will not go to CloudFormation for deployment and fail in the CloudFormation, right? And but I guess this should for NLB, I guess we can set it both true or false, but the default value is false for NLB according to the document. Right, so let's create an NLB for another check, a very quick check, okay? So at this moment, what we have learned from the console and document for ALB is that this option for ALB could be either undefined or true. You cannot set it false. But I guess for NLB, the default is false, but you probably can set it as true, but we need to verify from console. Okay, so let's go to CloudFormation attributes. Okay, availability zone routing configuration off. Okay, so the default is off. Let's see if we can turn on this option. Disable closed zone. Okay, you are allowed to enable. Okay, well, this is cool. So what if we turn on this option for ALB, NLB? I guess it would be handled because if we look at the source code, here, so when it will only be handled when it is turned on explicitly, right? But not handled when it is turned off, right? So let's check turn on diff. We should see the diff from NLB because this will be handled. Okay, yeah. So now we know that for ALB the default is true. And we only handle either this property is undefined or true, but we are not gonna handle false. But for NLB, oh, by the way, we cannot set it to false because it's not allowed based on the document and the console. And for NLB, we can set it both true or false. But the default is false, right? Okay, so yeah, let's see what we can do to improve the CDK experience, right? Now I'm gonna create a cloud IDE, cloud development environment. So if you look at my video for the previous PR last year, I was doing on a GitHub online IDE, but this year I'm gonna do it in AWS Amazon CodeCatalyst dev environment, which is a very awesome product, which comes with a dev environment cloud IDE that I can do with VS Code using my local UI while my instance is running on AWS from remote, which is awesome. So I'm gonna walk you through how to provision a cloud IDE using the Amazon CodeCatalyst dev environment. Okay, let's go to the Amazon CodeCatalyst landing page, CodeCatalyst.aws, and sign in. And for me, you can either sign in with your builder ID or IAM Identity Center, or aka AWS SSO. I have configured the Identity Center for CodeCatalyst, so I can sign in with the Identity Center. Okay, I'm in. So you need to create your space and your projects. So I already have a Pahoo demo, and the project is aws-cdk. So what I'm doing now is, first you need to fork from aws-cdk official repository on GitHub. You need to do it just once. So go to aws-cdk repository. You should click fork your own copy of aws-cdk. And after you create your fork in CodeCatalyst, go to the source repository. You can create a CodeCatalyst repository that link to your fork. So I'm gonna create a repo from code repository that links to my fork. Pahoo aws-cdk, let's link. Okay, so this is my link to my aws-cdk personal fork. So I'm gonna create a dev environment for this repo and use VS Code and alias optional, and dev environment configuration. Select the medium, at least the medium, so you can build up the aws-cdk storage repository. Storage, let's make it like 32 gigabyte. Timeout, for example, 4 hours. VPC support, I don't need VPC support. Okay, just create. Open VS Code. Okay, it's coming. Okay, now we are in the dev environment. It's a remote instance, but we are running from our local VS Code client. So we need to first open the github YAML document. So this is essentially what's happening when we open the repository with github YAML. The github will run the init commands for us, but in VS Code with CodeCatalyst, we do it ourselves. So just run the yarn install, followed by this and this. Okay, and node options and this. Okay, so this would take up to like 20 or 30 minutes, but yeah, feel free to grab a coffee if you like. Do not touch anything. Just wait for the building. Okay, now we are complete. After 18 minutes. So now let's check the source of the library. The code should be at this path. Packages aws-cdk lib AWS elasticloadbalancingv2 library shared base load balancer TypeScript. Okay, and scroll down to the cross-zone. Okay, so before we update any TypeScript code, we need to run a command yarn watch. So first, go to packages aws-cdk lib and run the yarn watch. So running yarn watch in a separate terminal like this. So this will compile any TypeScript you just modified into the JavaScript. Before we modify the source code, let's define our plan for this PR. We should expect that if user pass the props crossZoneEnabled to true, the L1 prop should set as true, right? In ALB as false, CDK should throw an error, right? So it will not go to the CDK deploy. ALB, if users pass this value to false, the L1 prop should set as false. Then we need unit tests. We need integration tests, right? Okay, let's do it. So I would like to do it this way. Okay, so if base props cross is not undefined, then we should set this value. Okay, depends on if this is true, then it should be true, else false, right? So when this property is defined either true or false, then the L1 attribute would set the value accordingly, right? Either true or false. But we need to capture this case only in ALB, right? So let's see if we can do that in ALB. Class application load balancer here. This will create a base load balancer, right? But we can do some check here. I would add another check. So if props crossZoneEnabled equals to false with ALB, then we should throw an arrow, right? Awesome. Yep. So that's it. We handled this condition and this condition, and this condition as well. Yeah. Then we need some unit tests and the integration tests, right? Okay, so after you change your code, the best way to validate your code is write a very tiny CDK application to validate. So you should go to the AWS CDK testing framework integration testing test and the package name and the test. Just create a new integ sample.ts with some very tiny sample code like this. For example, I just import the app stack EC2 elasticloadbalancingv2 from AWS CDK lib. Create a new app, create a stack, define my environment, and to avoid creating a new VPC, I just import my default VPC here to make it faster. And yeah, so for example, let's create an ALB here. And for example, let's say if the crossZoneEnabled is true, it should equal to true in the L1 property, right? So let's just do it. But before that, make sure to run a yarn watch at this directory, so it will just compile the TypeScript into JavaScript for you. And then open another terminal exactly at the same directory and run this command npx-cdk-a. -a indicates the application, and the application is the compiled JavaScript from that TypeScript. And you can first run a diff. Let's wait for the okay, yarn watch, no error. Okay, good. Let's do it. Okay, so we're gonna create an ALB and security group here. Now we just open the synthesize template. Open into the IDE. For example, code cdk.out template, cdk.out, and the stack name is demo stack, right? So it should be a demo stack template JSON. Open. Okay, we should have this file open here. So if you look at the attribute here, okay, it should be, it is true now. So which is yeah, expected. Great. So now if we make it false, make it false. For ALB, it should throw an error, right? Let's see if it does. Okay, you need to always wait for the real-time compilation. Okay, let's do it. Okay, we got an error thrown as expected, right? Which is great. So what if we leave this property undefined? And then this should be undefined, right? Let's see. Again, just wait for the incremental compilation. Okay, do it. Okay, awesome. This attribute was removed, which is expected, right? So I think ALB is good here for the three conditions: true, false, or undefined. And of course, you need to verify the network load balancer as well for the three cases, and yeah, check the synthesized output. So, yeah, so if everything is good, I think your integration testing is fine. We will run the real integration testing later, but at least I think the logic is good now. So I think now we should write some unit tests. Okay, so after your very tiny sample application for very quick verification, you should be ready to write your unit tests. So unit tests is pretty much at the same directory with the library. So go to the elasticloadbalancingv2 lib. Yeah, go to the elasticloadbalancingv2 test ALB load balancer test TS. You can write your test suite here. So for example, it describe crossZoneEnabled, I have 3 test cases. The first one is true. It could be true. It could be undefined. And when it is defined as false, we should expect an arrow to be thrown. So yeah, so that's it. Given we have CDK app stack VPC, when we provision an ALB with crossZoneEnabled as true, we should expect we have one ALB resource, and we should expect the resource property should be like it should have a load balancer attributes property with the content like this, right? And then when it is defined, it should not have that attribute at all, so only this attribute. And then when it is defined as false, we should expect this arrow to be thrown, right? Okay. For unit tests, you don't need to run the young watch, just young test. Okay, I'm gonna do it. Go to aws-cdk lib and run this command. Young test and the for path all the way to the TypeScript. Okay. Okay, we are good. So all passed, right? Good. So let's go to ALB. So ALB, same load balancer test TS. We create our 3 test cases here, right? It could be true, it could be false, and it could be undefined, right? Very similar to ALB. Okay, let's do it. Awesome. ALB all passed, right? So I think we are good in unit tests now. So let's write integration testing. We probably need to update our integration testing, especially the snapshots. So let's go back to aws-cdk testing, framework integration testing, and tests. Okay, let's just open our terminal here. Again, you need to run a young watch for integration testing. Then you can run the integration testing against all the integ tests under the elasticloadbalancingv2. So let's do it. Young. Okay, just do it. If the snapshots does not match, then you need to add another parameter, update unfailed, to make it deploy again. And on successful deployment, the snapshots will be updated. Okay. By the way, you should remove this sample, integ sample.ts. We don't submit this to the repository, right? Okay. So integration testing, the existing integration tests are all good. So we probably don't need to create a new one, given we have a very tiny sample application. Yeah, we can verify that it deploys, right? But for some pull request with like feature or bug fix, the linter the automation would require you to update the snapshots. So in that case, you probably will need to update any of the existing integration tests. So let's see if we can update somewhere. For example, we should be able to update this one and maybe this one. Okay, let's do it. Okay. Yeah, it's a very, very tiny application. Okay, so I guess maybe we can create a new one to cover this case. Okay, let's do it. Integ crossZone. I'm gonna create both NLB and ALB to cover this property, and we need the NLB as well. We need to use the integ test module. So import integ test because it's a new test. So we should use this module. Wait for the compilation. Okay, so it deploys with no error, and the snapshot should be generated. If we look at we will see some template JSON, SS JSON generated. We can switch to the view as tree. Yeah, all snapshots generated here. So we need to commit everything here and push to our branch. So now let's do it. Okay, but now we are gonna push to main, but I'm gonna check out to another branch. Let's call it crossZone. Okay, push. So now we are pushing to the CodeCatalyst linked repository, but actually CodeCatalyst will push to our fork on GitHub. So let's check the our GitHub repository. Okay, so we see the crossZone, right? And click contribute, open pull request. So now we need to write our pull request. So it should be a fix, right? Fix what problem to fix. And the issue number. So we are gonna close this issue. And the reason for this change. Yeah, and I guess we need to improve the doc string, but I'm gonna make submit the PR draft for now. So draft pull request. I think it and check this. I think it's okay for now, but we need to improve some doc string. So let's switch back to our VS Code. So I think I'm good. We are good. So this is a hint that you cannot do that. But if you really do that, we will throw an arrow to stop you because you are gonna fail on CloudFormation, right? Awesome. So it's a minor update and push. Okay, we got it. So I think it's pretty much of it. We just need to wait for the code build, the CI, to make sure that it builds with no error. Then we can turn on from draft to ready to review. Yeah, I think that's it. So in this video, we have spent quite a lot of time. We explained how we triage an issue, how to investigate, confirm a problem, figure out where is the source that caused this issue, and propose a solution. Write a pull request, write unit tests, integration tests, submit a pull request. So hopefully this pull request can be reviewed by the maintainer and get approved and merged. Then we can address the bug. Yeah. Okay. That's it. I hope you like it. Let me know if you need any help, and if you are interested to watch anything, any demo, please let me know. Okay. Thank you. See you.